Hi, my name is Rez. I'm a professional game programmer and I do electrical engineering as a hobby. This is the Electronic Sound Synthesizer Advent Calendar Day 5. Day 5, I'm guessing, is wire. I think they often give wire in these kits. I think I've done like 3 or 4 of them at this point. And look, I'm right. Oh, and an IC. Okay. Well, we have wire, which is slightly boring. We have an IC with some bent leads. This might be a 555 timer. That is my strong suspicion. I'm going to try and bend these leads back. Let's see what we've got. Can I easily see what this is? LM something or other. It's hard for me to see. I'll tell you what. I will zoom. See if I can get this guy to focus. Come on, friend. It's hard to focus. There we go. Can we see it? Yeah, a little bit. LM386. Ah, not a 555. So it's an LM386. I don't know what that is. I could look up the datasheet, but I'm pretty sure that this will tell me. Here we go. Behind the fifth row, you'll find the integrated circuit IC chip. And a roll of wire. The IC is an LM386 audio amplifier in an 8-pin plastic casing. A few additional components are required to reproduce even very weak signals at a reasonable volume. Yeah, so if you remember from yesterday, when we got this little pulse, we couldn't actually even hear it. So hopefully that's something that's solved here. They want me to assemble this socket. They talk about how these chips are numbered. This is pretty standard. If you can kind of see it, there we go. There's a little notch here at the top, and they're just numbered 1, 2, 3, 4, and then it goes across 5, 6, 7, 8, going back up, and you can see it here. So we have to put this guy in here, and we do a bunch of connections. And I don't have the pinout for this particular amplifier, so I'm not actually sure what is in here, but let's find out. Okay, so we're using pretty much every component again, very similar to how it was before. The capacitor is off, and we want to install this guy right here. Okay, so I'll just put that right there. Okay, so now we're setting this up in a slightly more traditional, I guess, fashion, where we're going to have these power rails, positive, negative. So we'll set that up. And I happen to have a little red one here. This is actually from a previous kit. And we'll just strip the other side of this wire, just like that. And so this will be my positive side. And, it's kind of sacrilege that I'm using blue, but that's okay. This will be my negative side. So that'll be my positive, negative for my rails. Let's see what else we got. So this looks like the LED. They're not even connecting the LED in this case. They're just leaving it in there for fun. So that's okay. Looks like we're not really doing much here either. Yeah, we're not really doing much there. So these guys connect. Okay, so we need a bunch of jumpers. I'm going to get my fancy jumper kit to make my life easier. Okay. If you're going to do little like prototype stuff, little protoboard stuff, this plastic is dulled over age, but it's all it is just a small kit with just little jumpers of varying sizes. That's all this is. I don't even remember where I got it. Probably a Christmas present or something one year. So if you're going to do this kind of thing, I very highly recommend having something like this. Zoom this down a little bit so we can see better. What have we got? So they're trying to connect pins 2. So we'll do pin 2. Man, I can barely see. There we go. Pin 2 and pin 4 both go directly to ground. Okay, so pin 2 and pin 4 are directly to ground. And then there's this sort of flyaway wire. I'm assuming this is like an antenna kind of thing that we're gonna do here. 5mm insulation. So they want this wire that is saying about 3 centimeters long. Fair enough. Close enough. Strip some of the insulation off. And that this is probably some antenna type thing that's going to live there. And before I lose these, let's put these guys back. All right, what else? What's next? So we've got the loudspeaker hooking up to the capacitor. So here's my capacitor with the positive end here in pin 5. This guy's coming back out here to this. This is the speaker, so we'll grab our speaker. We're going from ground to this negative terminal. Looks like we are tying this. I put these away too quickly. We're tying this to, is that right? Yep, that's right. Looks like pins 7 and 8 are just left floating. And I think that's right. I guess we'll find out. Let's turn this guy on. So I'm going to connect up my power supply. Hook that guy up there. We'll hook this guy up here. And I have no idea what we're supposed to actually see or hear from what this thing is saying. But I would expect to hear, if this is an antenna going into this chip, I would expect to hear something vaguely crackly or fuzzy. So let us see what happens. Yeah, a little bit. I don't know if you probably can't hear it. I'm going to try and put it up to the microphone. See if you can hear it. So as I touch it, I can hear it sounds like voices or whatever. So I'm picking up some kind of station or something. I very much have not cut this wire to any engineering specifications. If I had, I expect that I would actually be able to pick up wavelengths. So the way that antennas work is you want to have a particular length so that they can catch a particular wavelength. And essentially that's what you're doing when you have your antenna in your car or whatever. So that is largely what's happening. I have no idea if that's going to be picked up by it, but this is some kind of, I'll look up the LM386 data sheet in a minute, but that's basically what's happening here. So that's super fun. Let's take a look at it on the oscilloscope as well. And here we are back to the oscilloscope. I've just centered it because we're gonna so I'm not doing anything with it now. It's just the tiniest bit of noise that you can see. I'm at 200 millivolts per division, but as soon as I touch it, there it is. That's what we're hearing. It's that thing. So that's exciting. I can actually probably get a better look at this if I turn off the roll and we do something a little more fancy by setting up some trigger. Let's see, edge trigger, rising slope. Yeah, that all seems fine. We'll set up the trigger line to be about here or so. That gives us something. Let's do this. So if I spin this guy up. There we go. Let's do it like this. There, so and I probably need to set this as well. So we can see the signal. Come on, friend. There we go. So if I crank it a little bit like this, there's the signal. Now it's going to look a little dodgy because this is a digital oscilloscope. So it's kind of interpolating what's happening here. But of course, if I were to single step again, now I'm going to get some better, slightly better results. So we can kind of see, like, this is the waveform here that we can see what's going on. A lot of it's noise, but a lot of it is also just, you know, I'll go back to roll. A lot of it is the actual, like, whatever station we're picking up. Hold on, let me go back to just running an auto roll. So that's whatever's happening. So there you go. So that's exciting. I assume we'll be able to tune into stuff. Now this is similar to so I had a radio calendar. Oh, I built this years ago, maybe 4 or 5 years ago. Back before I was really doing any videos on this stuff. And that one was very similar. It didn't have this specific chip, I don't think, but it was quite similar. So I'm curious what's going to happen here with our little because this is an electronic sound advent calendar, right? It is, you know, build your own synthesizer. So I'm really curious where this chip is going to come in. I want to take a look at the data sheet.